So I'm not sure, David, if you got a chance to watch the videos of the previous classes. We are doing complex numbers. So just find some time to watch the videos of the previous two classes that you missed. You'll be able to catch up on that, and if you have any questions, I would love to answer those. Okay. So as part of complex number, we learned what is a complex number, what do we mean by real component and imaginary component of a complex number, how that I think came into picture. So I will just touch a little bit about it, and then we'll talk about what we want to do today. So we want to learn how do you multiply a complex number. Vishal.
Hi, sir.
How do you multiply a complex number? So today we are going to cover further concepts around complex numbers, where we'll talk about how do you visually multiply a complex number with a constant, with a complex number itself, and then how do we multiply and divide complex number by another complex number in the polar form. So let me just, I will not go into the detail of everything that we have covered in the previous classes, but we'll touch some of the concepts a little bit so that it becomes easy for us to relate. So as you all know, have heard about, if I'm talking about a complex number, I'm essentially talking about a complex number which has a real component to it and an imaginary component to it. Okay? And here I is nothing but, I is found as a substitute of square root of -1. So I is nothing but a square root of -1. So I squared will be equal to -1. So that's the basic premise of a complex number. Yep. And when we talk about a complex number being represented in a polar form, we are essentially talking about, Vishal, you can go on mute. Yeah. So when you talk about a complex number in a polar form, what we talked about is, so first thing is, a complex number can be represented, can be plotted on a complex plane, where instead of this being the x-axis, this is called the real axis, and this is the imaginary axis. So if you have a plus bi as a complex number, you can visualize that along the real axis the value is a. So this distance from here to here is a, and along the imaginary axis this distance is b. That's how you visualize a complex number in a complex plane. So the other thing that we talked about was that you can represent a complex number in this form, which is called rectangular form, a plus bi, or you can represent this in the polar form also, where you say you look at the distance from the origin to this point, this absolute distance, as your magnitude, and the angle that it makes with this positive of the real axis is called the amplitude, this theta. So it can be represented in, so if this distance from here to here is r, this is the magnitude of the complex number, meaning you can represent this complex number c in the polar form as r, this is the real component, so r cos theta plus I, this distance is b, which is nothing but r sin theta. Or you can represent this as r times cos theta plus I sin theta. This is what we have covered so far. Do you guys recall it, or it sounds new? Okay. How about Samriddhi, Vishal? Do you guys recall it? Okay. Vishal is not answering me. Okay. Vishal, you might want to go on mute, better.
Oh, sorry.
Yeah, no, it's okay. But so this is what we have covered. Now what we want to talk about is, how do we, so again, the first thing is, if I have, let's say, a complex number c as let's say 2 plus 3i. So first thing is, let's visualize that in the complex plane. This is my real axis, this is my imaginary axis. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, and I'm just writing as much that is minimal. So when I try to visualize this complex number in this complex plane, what is happening is, along the real axis this value is 2, along the imaginary axis the value is 3. So that means I'm talking about a point here. Yeah. And if somebody says find out the magnitude of this, you will say this is the magnitude, this length from here to here, from the origin of the complex plane to this point in the complex plane, this is the magnitude, which will be nothing but square root of 2 square plus 3 square, which will be 4 plus 9, 30, square root of 30. So this is the magnitude. And if somebody says, okay, find out what is the amplitude, meaning the angle that it makes with the real axis, you will say this amplitude is nothing but, let me put it this way, tan of theta would be, this is theta, tan of theta would be this distance by this distance. So that is, if you visualize this as a right angle triangle, this distance is 3 over 2. So far this is okay. Now, what if we multiply this complex number by 2? If I am talking about multiplying this complex number by 2, what would happen? When I am multiplying this by 2, what will happen? This will become 2 times 2, this will be 4, and this will be 2 times 3 is 6i. Yeah? Where this point is going to be 4 here and 6 maybe somewhere here. Are you guys with me so far? We are just talking about how do I multiply a complex number with a integer or natural number, whatever you call it. Okay. Now, what happens to the magnitude? So this is my new complex number after multiplying by 2. This is 4 and 6. What will be the magnitude of this one? It will be 4 squared plus 6 squared square root. Right? Davik, is it making sense so far? Okay. So this is nothing but 4 squared is 16, 6 squared is 36. It became 36 plus 16, 52, which I can write as 4 times 13, which is equal to 2 times square root of 13. Yeah. So, what do you see between this? What do you see the magnitude of the original complex number versus the new complex number after multiplying by 2? You just multiplied by 2. On the same axis, you multiplied by 2. I mean, basically this magnitude became double of its size. So whatever is your number you are multiplying with, that becomes the new magnitude just by multiplying by that number. So if you have, let's say, a complex number z1 equal to 2 plus 3i, if you multiply this by 3, the magnitude will become 3 times of its original size. Okay? Does that sound okay? And what happened to the amplitude? Amplitude did not change. The amplitude meaning the angle that it makes with the positive of the x-axis or the real axis. Does that sound okay, Samriddhi, Vishal, Davik, Praneeth, everybody? So, first takeaway is, if I have a complex number, if I am multiplying that by any constant, the magnitude gets multiplied by the same constant. Okay? and the amplitude doesn't change, meaning the angle that it makes with the real positive of the real axis, that doesn't change. So this is the first thing. So tomorrow if somebody says I have a complex number somewhere here and I multiply that by 3, you will think about it, okay, what is the distance, and multiply by 3. This is your new complex number. This is where it is going to be. Now this is okay when we are multiplying by a constant. What if a positive constant? Okay. Now imagine this complex number, let's say 1, 2, 3, 4. I have complex number C1 equal to 1 plus 1i. I'm just picking up a simple easy one, okay? 1 plus i. So that means my complex number is somewhere here, 1 and 1 here. If I multiply this by minus 1, what will happen? If this becomes minus, if I'm multiplying this by minus 1, what happens? It becomes minus 1 minus 2 plus minus I. What happened was, it came here, minus 1 minus 1. The magnitude will remain the same. But what happened to the amplitude? Earlier this was your amplitude. Now for this new complex number, after multiplying by a negative term, the amplitude got added by 180 degree or a pi. Am I making sense so far? So the simple takeaway here is, when you have a complex number, you multiply by a positive constant, you are extending that in the positive direction by that many fold. If you are multiplying that by the negative constant, if you are multiplying by negative number just by minus 1, you are flipping it by 180 degree. So your magnitude remains the same, but your amplitude got 180 degrees extra. Now let's club these two things together. If I say I have a complex number z equals 2 plus I multiply that by minus 3. What will happen? 2 plus I. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 2 plus I. My complex number was lying here in the complex plane. When I multiplied that by minus 3, what happened was, it became minus 6 minus 3i. So minus 6 somewhere here, minus 6. I'm just making it up. And minus 3i. So we are talking about 1, 2, 3, minus 3 here. It came here. So what you are seeing is, this amplitude, if you look at it here, this magnitude here is 2 square plus 1 square, square root 5. In this case, what is the magnitude? Minus 6 square plus minus 3 square. Okay, or you will not even consider the minus sign. It's that magnitude is nothing but the absolute length. So 0 minus 6 will become plus 6. So let's not worry about the sign here. You will just take the absolute value of this and absolute value of this, square them. Okay. So this became, the new magnitude is 6 square plus 3 squared. So that is 36 plus 9, 45. Where you will take 9 out, 9 into 5, which is 3 square root 5. So your magnitude got multiplied by 3, and since we are talking about multiplying by minus, it is coming in this direction, and this amplitude, the angle that it makes with the positive of the real axis, that got added by 180 degrees. So when you are multiplying just by constant, you are extending it. You're multiplying by negative thing, you are flipping it by 180 degree, and you are extending it by that many fold. So when you are multiplying by a negative constant, you are flipping it by 180 degree and you are extending by that factor. Does it sound okay? Samriddhi, Vishal, Davik, everybody okay? Simple thing. Multiply by positive constant, you are extending it. Multiply by negative constant, you are flipping it, and then you are extending it by the factor that you are multiplying it by. Okay. Now think about, and it's not always in the first quadrant. Okay. Let's say if your complex number is lying here and you multiply it by -2. So first thing first, it flips in this direction and this magnitude gets doubled in this direction. So this is your new complex number. Yeah, after multiplying by -2. So if you are multiplying by positive, it extends. If you are multiplying by negative number, it goes in the opposite direction with 180 degree. Yeah. And obviously your amplitude, whatever was your amplitude before, you are adding 180 degree to that. That's it. Now let's imagine what is happening when we multiply a complex number C1, let's say 2 plus I, with 3I. Or let's say if you are multiplying by just I, what will happen? So this marker is saying thank you. So let's go to another one. So let's say I had a complex number 2 plus I. I'm multiplying that by I. What will happen? Look at this. This is 2 plus I. So I'm talking about this point. Okay. Now when I multiply this by I, which is I times 2 plus I, what happened? This became 2I plus I square, which is 2I minus 1. Now visualize this one. 2I, so this is, let's say 1, 2. So I is 2 and minus 1. So we are talking about, so this was the magnitude. Now 2I, this is minus 1 minus 2. My new complex number is here. What you will see is, you just multiplied by I, it came here. Now let's look at what is the magnitude in this case. It is 2 square plus 1 square, square root. 2 square is 4, 1 square is 1, square root of 5. Now if you look at this guy, after multiplying by I, what is the magnitude of this guy? This is my new complex number. Its magnitude is again 1 square plus 2 square, square root, which is same as this. So when you are multiplying by I, what's happening is, you are rotating it by 90 degree. Now again, I'm forcing you guys to believe that you are rotating by 90 degree. Let's look at it. In this case, what is, if this is my complex number, this one, this angle theta is nothing but, what is the value of y? It is 1 over 2, which is 1 over 2. I mean, this is 1 over, okay, 1 over 2. I'm not talking about this. So this is theta. What is the magnitude? Square root 5. So here, I will say sine of theta is equal to this length, which is 2 by square root 5. Okay, 2 by square root 5. Yeah, and here in this case, what is my sine of theta? So sine of theta will be this length, this is 2. So sine of, if this is, let's say this is my, I'm saying, giving a name alpha. Sine of alpha, this angle will be 2 by minus 1. Sorry, 2 by, this is 2, and this the sine alpha will be this by this. So 2 by root 5. So what am I doing right now? I'm trying to find out this angle. Oh yeah, let's not worry about it. Let's not worry about it. Let's assume that this is 90 degree only. Now you will say why? Find out the slope of this line and slope of this line. They are, when you have, okay, so here what is your slope? Rise over run. 2 over 1. 2 over 1. Sorry, 1 over 2. I'm just messing it up. I'm trying to find out a simpler approach. So here, for this line, what is my slope? Rise is 1. Vertical component is 1. 1 over 2. Okay. And for this line, what is my slope? Rise over run. So it is, rise is 2 and run is minus 1. Now, when you multiply these two slopes, multiply, if this is slope m1 for this original complex number, this line which is joining this complex number with the origin, and if you look at this one as m2, m1 into m2 is equal to 1 by 2 into 2 by minus 1, which is minus 1. This is what you guys would recall from your geometry concept, that if you have two perpendicular lines, if you multiply their slopes, it will be equal to minus 1. Correct? Does that sound okay? Davik, Samriddhi. So again, just to do a recap, okay, what we did was, we had a complex number, we tried multiplying that by I. So what we saw was, my magnitude doesn't change, it just rotates by 90 degree. And just to convince ourselves, we are just applying different concepts to see that is this line perpendicular to this line. So we looked at the slope of this line, and we are looking at the slope of this line. Here my rise over run is 1 over 2. Here my slope is 2 over minus 1. Okay. So this is, when we multiplied the slope of these two lines, joining these two complex numbers with the origin, we saw that this is minus 1. That means this is perpendicular. So the takeaway or the interpretation from this whole thing is, when you are multiplying any complex number with I, you are not changing the magnitude. You are just rotating that by 90 degree. Does that sound okay? Now there's a riddle for you guys. What will happen if I multiply this by minus I? Any idea? Give me some creative answer. Praneeth, Davik, Samriddhi, Vishal, anybody? So what we saw was, okay, let me give you guys a quick recap of what we have done. We saw that when I have a complex number, when I multiply that by a constant, it extends. If I multiply that by a negative constant, it flips and gets multiplied by the factor that we have. We saw that when we multiply it by I, it rotates by 90 degree, the magnitude remains the same. Yes, Praneeth. So my question to you guys is, what will happen if I multiply that by minus I? Yeah, Praneeth.
Would this be the 90 degree rotation, but then you move it down into the opposite one?
Yeah, exactly. See, this will be the see, what we saw was, if I am multiplying by 2, I am going this direction. If I am multiplying by minus 2, I am going this direction. If I'm multiplying by I, I'm going this direction. When I'm multiplying by minus I, I'm going this direction. Or you can always think like this. If I'm multiplying by minus I, it is as good as multiplying by minus 1 times I. So first you multiplied by I, you went in this direction. Now you're talking about multiplying by minus 1. That means you're just flipping it by 180 degree. Yeah? Does it sound okay or not okay? Davik, Vishal. Now, think about it. Let's say I have a complex number 2 plus 3i. Okay? I want to multiply that by minus 4i. What will happen? So let me give you guys a situation here. So this is 1, 2, 3, 4, 1, 2, 3, 4. This is where my complex number is 2 plus 3i. It's here. I'm trying to multiply that by minus 4i. So how you have to visualize it is like this. So minus 1 times 4 times I. So this is your complex number. Do all the steps one by one. Let's say you multiply by I first. That means you are rotating it by 90 degree. This step is done. Now you are multiplying by 4, meaning you are making the length of this 4 times. This is where it came. Now when you are multiplying by minus 1, that means you are just flipping it upside down. This is where your complex number is. Yeah? Does it sound okay? So this is a problem this is one of the problems that you will come across in your city exams. And this is very easy to relate if you have that visual thing imprinted in your mind. Okay, I'm multiplying by this. Let me break it down. Simple. Now, does this sound okay to everybody? Davik and Vishal, are you guys with me? Samriddhi is very quick in acknowledging it. So is Praneeth. So I just want to make sure that all the kids are with me. Okay?
Yeah, I'm on response. I can't really click on my response.
What is it, Beta?
I'm on my phone, so I can't really click anything quickly.
That's okay, but my only objective is to make sure that you guys are with me. Okay? Now, let's look at another scenario. Now we are trying to, I have a complex number C1 as 2 plus 4i, and I have another complex number C2 as 3 minus 2i. If somebody says multiply C1 with C2 and find out the magnitude and the amplitude of the resulting complex number, and also find out what will be the new complex number. Okay? So this is the rectangular form still. We are not talking about multiplying complex number in polar form. So when I am talking about these two, let's go with simple math. So C1 into C2. Ultimately, at the end of the day, these are numbers. Meaning, if somebody is saying multiply, we'll multiply with whatever we know. Basic method. C minus 2i. When you do that, use distributive property, do it 4i times 3 minus 2i. It became 6 minus 4i plus 12i plus into minus 8i square. Okay. So, okay, one word of caution for you guys. Of late, some of my kids in the younger grades, they have started complaining about I miss the calculation at times. When I'm doing it 4 times 3, I write 8 and I'll assume that I've done it okay. So just pay attention to if I'm doing some calculation and I'm proving you guys right or wrong. Don't trust that I have done it right. Just be watchful, okay? So this became 6 minus 4i plus 12i is nothing but 8i, and this became minus 8 into minus 1, which is 6 plus 8i plus 8, which is 14 plus 6 plus 14 plus 8i. Now what is the magnitude of this one? Obviously you will say 14 square plus 8 square square root. This is the magnitude r, if I am calling it r. So r will be equal to 14 square is 256, no 196. Yeah, 196 plus 64. So this will be, yeah, whatever it is, 0. I hope I'm not messing it up. So from this you will find out the magnitude, and similarly this is your resulting complex number. If you have to find out the amplitude of this, you will say amplitude of this will be, this is my vertical component, this is my horizontal component, so 10 of this theta would be equal to 8 over 14. Okay, and then you will do inverse of theta equal to inverse of 8 over 14, 10 inverse of 8 over 14, or theta equal to arc 10 of 8 over 14, and you will find it out. So this is a very rudimentary method of multiplying complex numbers, okay, in the rectangular form. But if you have to multiply, if you want to use polar form to multiply these complex numbers, how would you go about it? Let me use simpler things that gives me a straightforward calculation. Okay, I'm picking up simpler this thing so that I get the value of the theta easily. Okay, so here when you have to solve this in polar form, or if you are given, let's say if you are given first complex number equals square root 2 cos 45 degree plus I sin 45 degree. This is your polar form. This is your magnitude and this is the amplitude. Okay, this is the polar form. Second complex number is square root, let's say again 2 cos 135 degree minus I sin 135 degree. So these are the two complex numbers that we have in the polar form. And again, for you guys to just make yourself more conversant with this, polar form is nothing but an extension of this thing when you can represent that in different form. Okay, where you deal in terms of the amplitude and the magnitude. This is amplitude or the angle that it makes with the real axis. This is your magnitude, which is nothing but the distance from the origin of the complex plane to the complex number. Yeah. When you have these two things, okay, and you have to find out, multiply C1 with C2 and find out the resulting complex number in the polar form and the amplitude of the resulting complex number as well. So when you multiply two complex numbers, you get a complex number. So you are given the complex number in the polar form. When you multiply them, what will be the resulting complex number in the polar form? So if you find that out, anyways, whatever you have as a constant, that will be your amplitude, magnitude, and whatever is the resulting angle, That will be your amplitude. So I sorry. I will here force you guys to believe something which is totally contrary to the way I teach. But what I'm saying is, when you multiply two complex numbers in the polar form, it will be, if this is let's say R1, I mean the first, this thing, second, this is the magnitude of the second complex number, it will be R1 times R2 cos of, this is, let's say this is first angle, this is second angle, cos of theta 1 plus theta 2 minus sine of I sine theta 1 plus theta 2. And now you will say from where this thing came into existence. What I'm saying is, if you have two complex numbers in the polar form, when you multiply them, it will become R1 times R2, meaning magnitude of the first one times the magnitude of the second one, in bracket sum of the two angles, cos of sum of the two angles, plus I times sine of the two angles. And if you know this, you can solve this problem in 30 seconds. You will say, okay, my resulting complex number C3 will be R1 times R2. My R1 is square root 2, this one is square root 2, so that will become square root 2 into square root 2, that gives me 1. And here cos of 45 plus 135, that is cos of 180 degree, plus I times sine of 45 plus 135, 180 degree. You can solve this in 30 seconds. But before you can solve it in 30 seconds, you have to be convinced that why this formula came into existence. Have you guys come across this formula before? Praneet, Samriti, Vishal, Davik. Okay. So let's look at it. We will look at this formula to convince ourselves. Because let's say my first complex number in the polar form is R1 cos theta 1 plus I sine theta 1. And my second complex number is R2 cos theta 2 plus I sine theta 2. Okay? I'm multiplying it, C1 times C2. This will be equal to R1 times cos theta 1 plus I sine theta 1 times R2 times cos theta 2 plus I sine theta 2. Okay? So here, and I am very poor when it comes to memorizing formula. Okay, so if the formula that I gave you guys, if that turns out to be different from what we will derive, that is, you can attribute that to my age and my memory. Okay, so let's derive it first. So these two are constants. So R1 into R2. This one we can keep outside, and then inside this cos theta 1 plus I sine theta 1 times cos theta 2 plus I sine theta 2. Yeah, so far it's okay. So at least the first part, the magnitude of both getting multiplied, that part seems to be okay. Let's see what is happening inside this big bracket. R1 times R2, and here when you break it, so this is, I will probably try saving some space. So I will multiply this thing with the whole thing, then multiply this thing with the whole thing. Let's see. Cos theta 1 times cos theta 2. Cos theta 1 plus cos theta 2, and then I will multiply cos theta 1 with this bracket. Plus I sine theta 2 times cos theta 1. This guy is multiplied with both of them. So far looks okay. Now I'm going to this one and multiply this guy with both the terms. So I sin theta 1 plus I sin theta 1 times cos theta 2 plus I square sin theta 1 sin theta 2. I hope I have broken these pieces together. Now this became R1 times R2. See, this is the mistake I was talking about. R1 to R2, I was tempted to write R1 plus R2. Here cos theta 1 cos theta 2 and sin theta 1 sin theta 2. I will put them together. Cos theta 1 cos theta 2 plus I square, which is nothing but minus 1 times sin theta 1 sin theta 2. This is one combination. This one and this one I have put together. Plus here I have I common, right? So I will keep I outside and in bracket I have cos theta 1 sin theta 2 plus sin theta 1 cos theta 2. Now when you look at this one, this is another formula that we have learned for adding trigonometric angles. This is equal to cos theta 1 cos theta 2. Cos theta 1 plus cos theta 2. This can be written as this. When you have cos theta 1 plus cos theta 2, that is equal to cos theta 1 plus theta 2 equals cos theta 1 times cos theta 2 minus sin theta 1 sin theta 2. Similarly, this cos theta 1 sin theta 2 plus sin theta 1 cos theta 2, this is nothing but is equal to sin theta 1 plus theta 2. This is about the formula for angle additions, trig angle additions. This one we had derived in one of the classes. I'm not sure if you guys remember this or you were present in the class or not. Pranit, do you remember having come across this derivation, this formula? No? Okay. So maybe I would have probably covered that in, oh I think, okay. I might have covered that in the other pre-calculus class. So anyways, I will cover this formula also, okay, in the next class. Because these are two trig functions with angle additions. These are formulas: sin theta 1 plus sin theta 2, sin theta 1 plus theta 2 equals sin theta 1 cos theta 2 plus cos theta 1 sin theta 2, and cos theta 1 plus theta 2, cos theta 1 plus theta 2 equals cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. I'm just trying to recall. I had explained this formula in one of the SAT classes, but anyways, I'll do one thing. I will explain that how to derive this formula in the next SAT class. Okay, this weekend I will explain this, and if I forget, please remind me. Okay. So what happened was you had two complex numbers. For now, again, I am giving you guys a problem for a problem. Okay, we'll come to that, and let's see if we know 15 minutes would not be enough to prove these two formulas. I think we'll need at least 30 minutes for both of them. So I'll do that. There's a unique diagram that I will draw for you guys to be able to digest that. So anyways, so here when we are trying to multiply two complex numbers in the polar form, it equals this, meaning the resulting complex number, when you multiply two complex numbers in the polar form, the resulting complex numbers magnitude will be a multiplication of the magnitude of the two complex numbers, and the resulting complex number's angle or the amplitude will be equal to sum of the two angles when you are multiplying them. So whatever angle you have, you just add them and that becomes your resulting complex number. So if you guys get familiar with this formula, you will see that you are able to multiply two complex numbers in 30 to 45 seconds and get the right answer without stressing too much about it. Otherwise, we always have the option of doing that in a simple form, multiplying all the factors one by one and then doing it. Okay. So I will show you guys the application of this one by doing few problems so that at least you can appreciate what is the whole concept behind multiplying complex number in the polar form. But are you guys okay so far or not okay? So another way to visualize this would be that if I have a complex number, let's pause this polar form of the complex number for a little bit. If you have a complex number z1 equals to 5 plus 3i and you have another complex number 2 plus I. When you are multiplying this complex number by this complex number, what is happening here is you will locate the first complex number, which is, let's say, here. When we multiplied a complex number by a constant, positive constant, it just extended by that much. Here, when you are looking at what you are multiplying this complex number with, how much it is expanding or shrinking would be determined by the magnitude of this guy. See, any complex number for that matter, how do you visualize that? As soon as we start talking about polar form of the complex number, we said, okay, fine. You know what? It's like velocity and speed, right? When you're talking about speed, you don't care about the direction. When you're talking about velocity, you're talking about speed, I mean the rate at which it's moving and the direction as well. So is the case with complex number. When you look at a complex number, it has two elements. It's analogous to the velocity thing, where you have the magnitude and the direction. So when you are multiplying a complex number by another complex number, you'll say, okay, whether it's expanding or shrinking will be determined by the magnitude of the second complex number. Let's say if the magnitude comes here 4 plus 1 square root of 5. So basically you are expanding it by this factor, square root 5, which is 2.32 or something. That much. And then whatever the angle of this guy, whatever the amplitude of this guy, let's say if this comes out to be 30 degrees, then you are rotating it by that much angle. This is a resulting complex number. And you can see that. You can multiply it, you can pick any two complex numbers, multiply them and then plot it and then look at the dimension of that and look at the magnitude and the amplitude both. You will be able to appreciate this. But the summary is, when you are multiplying a complex number by another complex number, you are extending or shrinking it by the magnitude of this number, and then the amplitude tells you by what angle it moves. Yeah? Does that sound okay? So if you compare that with what we were doing with the polar form of the complex number, same thing. We multiplied the magnitude, which told us, okay, you multiplied both the complex numbers and got the magnitude, which is the resulting magnitude of the multiplication of this complex number's magnitude and this number's magnitude, and then you added the angle. So this was the original angle, whatever was the second complex number's angle, that you added here, and that became your resulting amplitude. I hope you guys can relate to it. Somebody got scared of me, that is Vishal. Okay. So now let's look at few problems, and then that probably would clear a bit of dust for you. Okay. So far everybody with me, right? Okay. Let's look at one of the sample problem that we want to relate with. It says, suppose this is your this is given as I might not be doing a great drawing, but excuse me for that. It says suppose we multiply a complex number z by minus 1 by 3. Minus 1 by 3. Which point represents the product of z and minus 1 by 3? Choose answer. So I have complex number z here, okay? And every circle that you see, you can assume it to be referring to 1 unit, okay, along the real axis, okay? So this is 1, 1, this is 2, this is 2, 3, 3, okay? So z is here on the first, second, third, fourth, fifth, sixth circle, okay? When you are multiplying that by minus 3, if you have this complex number here, you are multiplying that by minus 1 over 3. And then you are having 4 options. A is somewhere here on the third circle. C is here. This is A, this is C, this is D, and this is B. So you have a complex number here, you are multiplying that by minus 1 by 3. Which point is representing the complex number after multiplying this complex number by factor minus 1 by 3? Any idea? And just for you guys to be able to relate, this is in the second circle, this is on the third circle, this is on the second circle, this is on the third circle. So between A, B, C, D, this is A, this is C, this is B, this is D. You have to tell me which one is the resultant of multiplying this complex number by minus 1 by 3. Yes, Praneeth.
I believe it's D.
You believe it's D?
Yeah, in the second circle.
Okay. Daivik, Samriddhi, Vishal, what do you think?
I'm still thinking.
Still thinking. Daivik, what is that you're thinking? Tell me.
Give me a second. Give me a second. I'm gonna keep like looking at my notes.
Vishal, how about you?
I'm just leaning toward B or D.
B or D? It has to be one point based on what you assume. I will let Praneeth describe it, okay, so that we can jump onto one more problem on multiplication of polar coordinates.
I think it might be D.
You think it's D?
Yeah,
Okay.
I'm not sure though.
Okay. Praneeth, do you want to describe why you thought it's D, which somebody is also agreeing to?
So, it's negative 1/3 multiplied by, so it's gotta be B or D, because when you multiply the negative, it flips over into the opposite quadrant, and that's what Z is. And then, Z is in the sixth circle. Well, so then you have to multiply by 1/3, and then I decided 2, so like it would become 3, and then 2 times 3 is 6.
Yeah. So that is the right approach, okay? So again, it's just a recap of this one, right? So when I was stressing on visualizing this one, this was the idea that okay, you have a complex number, you're multiplying by minus. So you can always look at minus 1 times 1 times 1 by 3. You can break this into 3 pieces. When you are saying minus 1, this simply flips over. This is where it comes. Now you are multiplying by 1. So minus 1 is just flipped over and 1, okay. Let's say you multiply by 1. So you are coming to the same point. And then you are multiplying by minus 1, which just flips over by the same magnitude in the opposite direction. Here. Then you are talking about 1/3. If it was 2, it would have extended. It is 1/3. It is shrinking. By what? 1/3 factor. So this whole length is 6. It will be 1/3 of that. That will be 2. And which is where the D is. Yeah? Correct? So always try breaking it into smaller pieces. Okay? And that will give you enough clue. If this would have been minus 1 by 3 times I, you would have come here and then I. Another 90 degree you would have added. You would have come here to this place. Yeah? And see the magic here. If it would have been into I, one more I, it would have again rotated by 90 degree and come back to this point. Again, I into I is what? I square, which is minus 1. Minus 1 times minus 1 times 1/3. This became 1. See? You have the same point. So I rotates it by 90 degree in the anti-clockwise direction. Always. Factor extends it. Negative sign flips it. These are some of the basic tricks that you have to picture in your mind so that when you come across this, it will be easy. Yeah. Now, I know we are almost top of the hour, but I will still stretch it by maybe a few more minutes, okay? 3-4 minutes. Just to see what happens when we are dealing with this problem. Let's say I have a complex number in the polar form, okay? W1 equal to 12 times cos of 3 pi by 2 plus I sine 3 pi by 2, and WQ is 2 times cos of pi by 2 plus I times sine pi by 2. And somebody says multiply W1 into W2 and find out the amplitude and the magnitude of the resulting complex number. Just by looking at this, it will look scary. But if you remember, we just saw one formula which says when you are multiplying two complex numbers W1, W2, it will be magnitude of this times magnitude of this. So 12 times 2 in bracket cos of angle 1 plus angle 2 plus I of sine angle 1 plus angle 2. You have the answer in 30 seconds. This is 12 times 2 is 24. Cos of 3 pi plus pi by 2. 3 pi by 2 plus pi by 2, 4 pi by 2, that is 2 pi. Cos of 2 pi plus I sine of 2 pi. And you know what? This resulting complex number is cos of 2 pi. If you visualize this in the unit circle, when you're talking about 2 pi, you are making a complete circle and coming back to the same point, which is as good as 0. Cos of 2 pi will be equal to cos of 0, which is 1. Sine of 2 pi will be sine of 0, which is 0. So this complex number is nothing but 24 times 1 plus 0. The value of this complex number is 24. Yeah? So the imaginary component is not there actually. When you are multiplying these two complex numbers, you are getting this. Does that sound okay? So please remind me in the next SAT class, I will prove these two formulas, sine of a plus b equals sine of a, sine of a cos of b plus cos of a sine of b, and sine of cos of a plus b equals cos a cos b minus sine a sine b. Okay, all right. So then if these two formulas can be proved, then you guys will have no complaints with me insisting on you guys to remember this formula. And again, it's not memorizing the formula, okay? These two formulas, just because I have proved that in one of the classes, even if it's been more than 35 years, I could recall that. So when you see it happening, right, it just comes down to how you relate to it and how you break it down, and it will be easy. Okay. So when you're talking about multiplying the complex numbers in the polar form, you're adding the angles. When you're talking about dividing the complex number in the polar form, you're subtracting the angle. So that is what will happen. I can show that division part in the next class, and there's one more concept called fundamental theorem of algebra that we did not cover today. So we'll cover that, and that will conclude this unit on complex number. And beyond that, if you guys find some more interesting problems, some missing concepts on complex number, you guys hold up me. Otherwise, after the next class, we will move on to the next unit. Alright? Does that sound okay to everybody? Alright, so have fun. Talk to you guys soon.
Yes,
Okay, yeah, bye-bye.